All right, you guys, lesson 124, conditions of congruence, proofs of congruence, and isosceles triangles. So the first thing that you want to write down are the 4 ways that we're going to learn we can prove that 2 triangles are congruent. So congruent means exact same size and shape, okay? So we'll say these 2 triangles here are congruent, and that's the symbol for congruence, by side, 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 meaning that we have equal sides here, and we have equal sides here, and we have equal sides here. So if you have 3 sides congruent, that means that the triangles are congruent, all right? Okay, we can also prove congruence by angle, 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 side. So if you know 3 angles and 1 side, so that means I know this angle is congruent to this angle, I know this angle is congruent to this angle, and I also know this angle is congruent to this angle, so all 3 of them. And I know at least one side. It doesn't matter which one, so let's say we know this side's congruent to this side. Then I have angle, 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 side, which proves congruence. All right, another one is side, angle, side. So you want to think of it as kind of going around in a circle. Maybe you're reading this way, but your angle has to be in between your 2 sides. So let's say that this side's congruent to this side and this side's congruent to this side. Then it has to be the angle in between. So this reads side, angle, side. So as you go around, again, the angle is in between the 2 sides. That one also proves congruence, okay? And the last one is HL. HL stands for hypotenuse leg. This only works with right triangles, okay? So the first thing you have to prove is that you have right triangles. And then all you need is the hypotenuse is congruent and one leg is congruent. All right, and then you have HL. So as soon as you see a right triangle, check for HL, but it may not be HL. It could be side, angle, side, or some other triangle property, okay? This is the one you have to be careful of, okay? This guy right here. If you have side, side, angle, it spells a bad word backwards, all right? That one does not prove congruence, all right? Why not? Why does side, side, angle not work? So right here, we actually have side, side, angle, and side, side, angle. So I have 2 congruent sides and then the angle. So again, as I'm reading around side, side, angle, the angle is not in between the 2 sides. Are these triangles congruent? No. However, I can switch this, maybe not, hold on, so that I see this other triangle. Well, now they are congruent, so it's side, side, angle. But it's not necessarily true because we don't know if it looks like that or it looks like that. So don't use side, side, angle ever to prove congruence. This guy, no. All right. Okay, you want to write down reflexive property. Reflexive property means that they share a side or maybe they share an angle. So right here, if you're looking at this triangle here and this triangle here, they share this side. So you would write BD is congruent to BD. This is by reflexive property. Okay, another thing they could share is an angle. So let's say you have 2 triangles like this. One's embedded in the other one. Notice the big triangle and the little triangle share this angle. Let's say it's angle A. We could say angle A is congruent to angle A. That's also reflexive property. Okay, angle, angle means angle, angle, angle. So this right here is important, you guys. If 2 angles are congruent, so is the third angle. Okay, we already know this because why? The triangles have to add to 360. So if I already know that this angle is congruent to this one and this one's congruent to this one, then this third angle here, they have to add to 360, so they're going to be congruent. It's kind of like by triangle sum, if you want to think of it that way, because they have to add to 180. But you can use this if you know 2 angles, you automatically know the third angle is congruent. We also have definition of midpoint. And midpoint is exactly in the middle, right? So that would be the midpoint. Let's say this is segment A, B, then C is the midpoint. What do we know if we have a midpoint? What we know is this piece is congruent to this piece. I know AC is congruent to BC, right? So here to here has to be congruent to here. It splits it in half, and you can say by definition of midpoint. All right, bisect is really similar. Bisect, though, is talking about an angle. So let's say you have this angle right here. Bisect splits it in half. So we put this right in the middle. So this angle, or this line right here, it bisects the angle. That actually means it splits it in half. So now I know that this here is congruent to this here. And we could label these two angles, the top one and the bottom one. And again, it would be by definition of bisect if you're going to say that they are congruent. Okay. All right, so we're just going to look at these four and we're going to figure out which property proves that they are congruent. Okay. So again, you kind of want to read in a circular fashion, and I've got angle, side, angle. Well, we don't have that one, but there's something in the picture that we know we can use, and it would be back to something I just explained. What other angle do we know is congruent? Well, these two angles are congruent, so I definitely know that the third angle is congruent here because of triangle sum. But the reasoning is two angles congruent means three angles are congruent. So now I have one of the triangle congruence properties, and that would be angle, 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 side. I would like you to write both this statement and the triangle congruence property. Okay, so over here, there's something in the picture that you're looking for, either an angle or a side that's congruent, and then we have congruent triangles. And the thing you're looking for is right here. This side is congruent to this side. And so I have reflexive property. All right, because xz is congruent to zx. And so what triangle property do I have now? So again, that's of just the four. You're always trying to find one of these four. And we've got side, angle, side. Okay. Okay, this next one, we have another shared side. So what property is that? Good. So we would write reflexive property. And now my reasoning for this one is side, side, side. Okay, this one's a right triangle. Don't assume that it is HL, but check if it is HL if you have a right triangle. And so we have another shared side. What property is that? Good. It is reflexive property again. So we could say AC is congruent to CA. And then I would use HL. We have a hypotenuse and a leg, and we know it's a right triangle. Okay, this is one of the problems from your homework. So if you want to stop, pause it, and print it off, and then do this one with me, that would be great. So every time you do these, I want you to do 2 columns. And on the top left here, you're going to write statements. And over on this side, you're going to write reasons. Okay, you always rewrite the givens first. So the first thing I'm going to write, and I put a little step 1, is angle A is congruent to angle B. And I really want you to mark it on the picture because you want to see it. So angle A is this angle here, is congruent to angle B. So mark those congruent. And the reason for these first 2 is going to be given. Anything that's given, the reason is given. All right, the next thing we can write is that side CD is congruent to side CE. So CD is congruent to side CE. Be sure you mark it with a congruence mark, and we write given. The next things that you will be looking for is something in the picture that you know is congruent. whether that's a side or an angle. So is there a side or an angle that you guys see that you know is congruent? Hopefully, you can see that these two right here are vertical angles. Okay, that is another reason you are allowed to use is this vertical angles. So that's going to be my third step. And I'm going to write, I can't just say angle C because I don't know which one it is. You have to use three letters for this inside angle here. So I'm going to say angle ACD, so C has to be in the middle, is congruent to angle BCE. And again, C is in the middle. The reason is VA, and you're allowed to use VA for vertical angles. All right, so now there's one more thing that we can see in the picture, and that is if we know two angles are congruent, we definitely know a third angle is congruent. This time I can say angle D is congruent to angle E because it's obvious it's this angle instead of kind of all these four ones, all right? And this reason is if I know two angles are congruent, I know three angles are congruent. And I want you to write it like that. Okay, the final step will always be this last thing that we're trying to prove. In this case, we're trying to prove the true triangles are congruent using one of these four properties, all right? So my last step is to repeat exactly what that says there. Triangle ACD is congruent to triangle BCE. And your reason over here is always one of those properties. And so this one is angle, 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 side. Okay, it should look exactly like this, and then you are done. Sometimes you'll have 4 steps, sometimes you'll have 8 steps, so there's not a fixed number of steps. All right, you guys, I am going to skip this one, but I am going to do this one from your set. Okay, so what's the first thing we always start with? That is right. Start with statements, reasons, and your given. So statements, reasons. If nothing else on a test for this, you should be able to at least state the givens and the final step. So my givens, I'm repeating side AC is congruent to side BC, and I always put given. So AC is congruent to BC. Mark it on the triangle. And the next step is this next given. Angle ACD is congruent to angle BCD. So when you read these angles, or you're wondering which one it is, trace it, ACD. And it's that middle angle right there. And the other one is BCD, and it's this angle right here. All right, and that's given. Okay, my third step is something in the picture. So you're looking for vertical angles, midpoints, or reflexive properties, any of those things we've already been over. So does anyone see something else that's congruent? Okay, hopefully you see that there's a shared side. So I can mark this side congruent. And so I can say that CD is congruent to DC. So I'm going this way and then I'm going the other way, but they are congruent sides. And the reason is reflexive property. Then you check, do I have one of the congruence properties? And if you kind of go around one of these circularly, you've got side, angle, side. So I can now say that the triangles are congruent, and we're going to state this last thing here. Triangle ACD is congruent to triangle BCD. And the reason is side, angle, side. So you always want to have one of your congruence properties here at the end. All right.